Hey guys, Mr. Covey here. Sorry I couldn't be in class today. My son's sick. Okay. But what I wanted to do in this video was first explain what you're going to be doing in class today, which is exactly what I had planned because I think you guys can handle it without me there. And then I'm also going to do the intro notes part of the class. Okay. So first, for just the general game plan, you need to watch this video. So watch this video. Take notes in your note packet. As you watch this video, I'm going to remind you guys about composition of functions. That's kind of the topic for today. Cool. After you watch this video, you guys are going to do the locker activity I wanted you to do. I will explain that now. So the locker activity is going to be fun. Basically, the idea is I have these green sheets printed. The sub will pass them out to you, and it's a little like scavenger hunting thing where you can look at each other's slides and try and find a person that fits each of these little descriptions. I'm not sure you can actually find them all, but it's a challenge. Okay? So if you go onto Schoology after you watch this video, you will see virtual lockers for 4th period or 8th period. If you click that, I put all your guys' lockers together. And so what you can do is look through people's lockers, just kind of read them. And as you do that, there's this little thing you can fill out. You can find someone who has a dog, fill them in on the little chart thing. You can find someone that fits all those little different categories. The purpose of this is for you guys to read other people's lockers, talk to each other, get to know each other better. Cool. The little scavenger hunt part is just kind of a fun thing to do with it. Cool. Okay. Awesome. So I'm going to do these notes. After you finish these notes, you guys are going to do that locker activity. I'm going to let you guys take a 4-minute break. When you guys get back from the 4-minute break, there's some practice in your note packet that you're supposed to do related to what I'm going to do in this video. And the practice is on pages 18 and 19, just so you guys can totally work together on that. And I'll try and make sure that I put up a key for that practice, an answer key, so you guys can check your answers. That's kind of game plan. Watch this video. Do the fun locker thing. You guys can take a break. You guys can do this practice. Yeah, let's get into the math then. Cool. Take a minute. This is function composition. Find out where this is in your note packet. Okay. Take a minute. Pause. Do these 3 problems. Those are all plug-in ones. Check. Please be careful here. That should actually be positive 110, my bad. Negative 3 cubed is negative 27, negative 27. Math is terrible, Mr. Covey. Oh no. Come on, Mr. Covey. Negative 5 times negative 27. Yeah. Is 135, positive 135. Plug in 2. 4 squared minus 1, 16 minus 1, 50. Plug in ones. What all of these have in common is that the inputs are numbers. I know what you're thinking. You're like, what else would the input be besides a number? We'll see in a second. But all of these have in common is the thing that you're sticking into the function is a number. And when you stick in a number, the thing that you get out is a number. The output is a number. Okay? Alternatively, the input can have variables in it. When the input has variables in it, the output has variables in it, usually. Okay? So if I ask you to find f of t, all I'm asking you to do is to take your function and stick t in the place of x. That's it. I'm asking you to do h of t plus 2. Everywhere there was an x, I'm going to put a t plus 2. I'm going to replace all the x's with t plus 2. Which is the same thing you did here. Here you replace the x with 2. Here we're replacing the x with t plus 2. The thing in the parentheses is what you replace the x's with. The only thing that's a little different with this is the thing that we're replacing the x's with has variables in it. It's not too bad, don't worry. We'll do some more. In general, what I want you to think about us doing in general is substitution. We're sticking something, sorry, my writing's so sloppy with this. We're sticking something in the place of a variable. Now, what can you stick in the place of the variable? You can stick a number, or you can stick other variables. Okay? But in either case, we're doing substitution. Ready? Here's my function. The thing I'm substituting in isn't just a number. I'm going to substitute in x plus 3. The way I like to think about this is my function, my red function, is x squared minus 6x plus 2. Something squared minus 6 times something plus 2. I'm replacing all the x's with gaps. Now what can I stick in the parentheses? I could stick a number in there, but this problem is asking me not to just stick a number in those gaps. It's asking me to substitute in x plus 3 into those gaps. So everywhere there was an x, I'm putting an x plus 3. Sticking x plus 3 in the place of the x's. And now I should do some simplifying. How do you do x plus 3 squared? Well, you do x plus 3 times x plus 3. Distribute x squared plus 6x plus 9. Distribute that negative 6. Combine like terms. Minus 9. Negative 9 plus 2 is negative 7. X squared minus 7. When you take f of x and you plug in x plus 3 in the place of x, you get out x squared minus 7. Okay. Please note what we did not do, and this is the common mistake, pay attention here. A lot of people look at this and they think, oh, so you take your function and you just add 3. No. We're not just adding 3 at the end. We're replacing all of the x's with x plus 3. It's more complicated than that. You guys pause and give this one a try here real quick. Here's our function. Find f of 4x minus 1. Pause, give it a try. Actually, I want you to pause and try this. Okay? So I'm taking my function. Everywhere there was an x, I'm putting 4x minus 1. Instead of doing x squared, doing 4x minus 1 squared. Instead of doing minus 6x, I'm doing minus 6 times 4x minus 1. After this, I'm just simplifying it. Okay? And I end up getting out this. Tonight. Cool. Remember, you shouldn't be using your calculator. This is a non-calculator unit. We should be doing this without our calculator. Cool. I'm going to do one of these with you. I want you to do the other one. I'll do this one with you. F of negative 2x. If you want to write it out with the shells, I like it that way. That's what always makes sense to me. Here's my function. 5 times something squared plus 2 divided by that thing plus 4. I could stick a number in the place of x, but this is asking me to do f of negative 2x. It's asking me to stick negative 2x in the place of x. And then I just want to do a little simplifying. Negative 2x squared is 4x squared. 5 times 4x squared is 20x squared. And then on the bottom, I just have negative 2x plus 4. No additional simplifying to do there. Just leave it like that. Pause. Try B, please. Okay. I'm sticking x squared in the place of my x. So I'm doing 5 x squared plus 2 divided by x squared plus 4. Remember, when you x squared exponent to a power to a power, you multiply the exponents. So it's 5x to the 4th plus 2 divided by x squared plus 4. Cool. Okay, let's move on. What we're really doing there is sticking a function into another function. We're substituting a function into another function. The fancy name for that is composition. Yeah, that's just substituting one function into another function. Okay. If you look at this problem here, this is not multiplication, it's composition. It's not f of x times g of x, it's f of g of x. Okay? What you're doing here is you're taking f and you're sticking g of x into f. You're taking g and putting it into f. The easiest way to think about this is to go f of, what am I doing f of? Oh yeah, of literally g of x. So I'm doing f of negative 5x cubed. And if you look at it now, oh, this is the same thing we were doing on the previous page. I'm going to take my f. Everywhere there's an x, I'm going to put a little parentheses. In the space of x, I'm going to put negative 5x cubed. And then I'm going to simplify. What's negative 5x cubed squared? 25. X cubed squared is x to the 6th. Minus 15x cubed plus 2. Cool. Composition. I took g and I put it in the place of x into f. I stuck g into f. Okay. This is the other notation you'll see for it with this little open circle here. If it's a closed circle, it's multiplication. So you can do like h times f. But if you see h circle f of x, that's another way to say composition. It's in kind of old school way. Usually now you see it like this. H of f of x. We're going to stick f into h. H. And we're sticking x into it. Excuse me, we're sticking f into it. And h of x squared plus 3x plus 2. Take h. Remember where there was an x? Right, x squared plus 3x plus 2. There's our new function. We're getting a new function by taking f and sticking it into h. We're getting our new function. It's called composition. Cool. Do 3 real quick. Go. Pause. Do 3. Cool. So I'm doing c of square root of 9x minus 4. So I'm sticking square root of 9x minus 4 into c in the place of x. The square root and the squared cancel. I get 9x minus 4. Okay. Notice this next problem looks slightly different. It says c of b of 2. Okay, now I'm not sticking a function into another function. They're actually giving me a number. The way to do one of these ones where you actually have a number on the inside is to work inside out. Definitely work inside out on these. Work from the inside to the outside. And start here. B of 2. I'm going to take B and I'm going to stick in 2. 18 minus 4 is 16, square root of 16 is 4. And when you get that answer out, you then take that answer, and that's the input into C. So whatever you got out for B of 2, you stick that into C. And now we're going to do C of 4. I'm going to do 4 squared, we get 16. So just notice that if the inner function actually has an x value to stick into it, then your answer you're going to get out is a number. Right? Because then you're actually sticking a number in, getting an answer out, and then sticking that into the outer function. Just work inside out with those. Cool. I want you to do 5 and 6. Pause. Do 5 and 6 a try. Okay. For 5 here, a of x squared. Because c of x is x squared. Sticking x squared in. To a, I get 3x to the 6 plus 5. For number 6, I'm actually sticking a number in, so I'm going to stick negative 2 into C. I'm going to get out 4. That's what I'm going to then stick into A. Got to do a little bit of arithmetic here. You got 197. Please make sure you're practicing the arithmetic without your calculator. We can skip 7. Cool. You can also do this with a graph. Okay, so for these ones saying what's f of g of 6, I like this other notation. I don't like the little circle thing. You don't see it very often. How do you do this? Well, you do g of 6, and then whatever you get out, you stick it into f. How do you do g of 6? Well, I don't have an equation to stick 6 into, but I have a graph. In other words, when my input is 6, when my x value is 6, what's my y value? I'm going to do this inside part first. I'm going to go to the graph of g. I'm going to go over to x is 6. 1, 2, 3, 4, 5, 6. And I'm going to say, oh, my y is negative 2. So g of 6 is negative 2. When you have an x value of 6 in g, the y value is negative 2. Once I do the inside part, now I'm ready to do the outside part. What's f of negative 2? I'm going to go over to the f graph. I'm going to go to an x value of negative 2. I'm going to see what the y value is. It's 2. Please pause and give this one a try. G of f of 6. Work inside out. You should start by looking at the f function. F graph. Give it a try. Cool. So f of 6 is 2. When I go to the f graph and I go to an x value of 6, I get a y value of 2. And then when I take that output and I make that the input into g, I do g of 2 and I get out 0. Last thing I want to show you is, remember this idea of breaking the function apart, decomposing it? I want you to be able to do this with composition too. So I want you to be able to look at a function like this and say, that's kind of like one function stuck into another function. That's kind of like composition. It kind of looks like the outer function, the big function, is what? Well, it's like 6 to some power minus 5. That's what I think about. It kind of looks like 6 to the x minus 5, only the inner thing, the x, isn't just an x, it's a 3x plus 8. So it kind of looks like someone took 6x minus 5 and stuck 3x plus 8 in the place of the x. F of g of x. They stuck 3x plus 8 in the place of the x in 6 to the x minus 5. That's what it kind of looks like to me. I'd like you to be able to think about that. That will help you next year in calculus. I am will use that idea this year too. But this is kind of like 3x plus 8 stuck into this function. Let's do these together because they're kind of hard. For this next one, I kind of think of the big function as it's kind of like 9 log of x. That's kind of what I think about as the outer function. But then what they stick in the place of the x? X squared. That's kind of how I think about this one. It's 9 log x with an x squared stuck in the place of the x. This last one's a little tricky. I'd look at this and I'd think, this is just 2 over x. Only in the place of the x, they put a 12x minus 17. So then if you thought about f of g of x, you'd get out that. That's a little tricky. Okay. All right, so to recap what we're doing next, you guys are going to pause. You guys are going to do that locker activity. You guys are going to take a break, and then you're going to practice on pages 18 and 19. Okay? Work together on this. Cool. I think you guys can figure this out. Okay? I do want to do one example. Maybe I'll do like example number 8. Yeah, I'll do example number 8 with you guys. Okay? On that page, I think we're on page 19. I'll do this practice problem with you guys. Ready? F of x plus h minus f of x all over h. This looks complicated. I promise it's not too bad. Let's break it down. 3 parts. Blue, do blue first. How do you do f of x plus h? Well, you take your f function, 4x plus 5, and you replace the x with x plus h. Right? That's what f of x plus h means replace all the inputs with x plus h. Replace all the x's with x plus h. With me so far? Yeah. Cool. The green part is just the original function. So now I'm going to subtract 4x plus 5. And then going to put that whole thing over h. What's h? Just some variable. And I'm going to do a little simplifying here. Let's do this together. Distribute the 4. I get 4x plus 4h plus 5 minus 4x minus 5 all over h. Combine like terms. 4x's cancel. 5's cancel. I'm left with 4h divided by h. What's 4h divided by h? Just 4. So a lot of stuff ended up, oops, sorry guys. A lot of stuff ended up canceling that problem. That's not a coincidence. This is it's a formula we're going to learn about later in the year. Yeah, but I just kind of wanted to show you guys that you can do the algebra part of it right now. Cool. Work together. I'll post the answer key for this stuff. You guys can do this. All right. So now you should pause where you're at. Everyone should be wrapping up roughly the same time. You're going to do this locker activity, take a break, and then you're going to do that practice on pages 18, 19. Cool. I'll be back in class on Friday. Please try and be productive. Thank you, thank you, thank you.